Ever dreamed of building rockets or designing spacecraft to explore the galaxy? Buckle up, because aerospace engineering is your ticket to the stars. From soaring through the skies to navigating the cosmic unknown, this field is all about pushing the boundaries of what's possible. In this video, we're breaking down everything you need to kickstart your journey into this thrilling career. What you'll study, the latest industry trends, job opportunities, and a peek into the daily life of an aerospace engineer. Ready to launch your future and discover what it truly takes to conquer the final frontier? Let's blast off and explore the real-world excitement and challenges of aerospace engineering. The world of aerospace engineering. Aerospace engineering goes far beyond just building rockets and spaceships. It's a blend of science and creativity dedicated to designing, developing, and testing everything that takes flight, whether it's gliding through the atmosphere or launching into the vast reaches of space. From designing cutting-edge aircraft and developing sophisticated satellites to creating futuristic spacecraft, aerospace engineers are the visionaries behind the machines that defy gravity and explore new frontiers. Aerospace engineering has a rich history filled with daring innovation. It all started with the Wright brothers in 1903, who defied gravity with their first powered flight. Fast forward through decades of innovation, from Chuck Yeager breaking the sound barrier to the Apollo missions landing humans on the moon. Today, we're in the era of SpaceX and Blue Origin, where reusable rockets and ambitious plans for Mars colonization are turning science fiction into reality. Aerospace engineering is like a two-lane highway to adventure. Aeronautical engineering deals with aircraft that navigate within Earth's atmosphere, like commercial planes and military jets, while astronautical engineering takes on the great beyond, focusing on spacecraft that explore outer space, like satellites, space probes, and interplanetary rockets. So, how do you get started on this incredible journey into the world of aerospace engineering? It all begins with the right education and a set of essential skills that will prepare you to build the future of flight and space exploration. The path to becoming an aerospace engineer typically starts with a bachelor's degree in aerospace engineering or a related field, but the sky's the limit. Many continue to earn master's or even PhDs, specializing in niche fields like propulsion systems or spacecraft design. Aspiring aerospace engineers dive into subjects like physics, calculus, materials science, and fluid dynamics. They'll also tackle control systems and computer-aided design, which are critical for crafting the next generation of aircraft and spacecraft. It's important to know that success in aerospace engineering requires more than technical know-how. You'll need sharp problem-solving abilities, critical thinking, effective communication, teamwork, and proficiency in CAD software and programming languages. To prepare, focus on math and science in high school, join robotics clubs or science fairs, and take online courses to get ahead. If you've ever wondered what it's like to work in aerospace engineering, imagine a world where the skies aren't the limit, they're just the beginning. The field offers a variety of exciting career paths that cater to different interests and skill sets, all united by a common goal: pushing the boundaries of flight and space exploration. Let's dive into the universe of opportunities that await you in aerospace engineering. Career opportunities. First, let's talk about the more traditional roles in aerospace engineering. As an aerospace engineer, you could find yourself working on the design, analysis, and testing of both aircraft and spacecraft. These professionals are the backbone of the industry, ensuring that every plane in the sky and every rocket launched into space is safe, efficient, and up to the latest standards. Then there are avionics engineers, who specialize in the electronic systems used in aviation and space vehicles. From navigation systems to communications and weather radar, these engineers make sure pilots and astronauts can operate their machines effectively and safely. For those intrigued by the science of propulsion, becoming a propulsion engineer might be your calling. These engineers focus on the engines and fuel systems that power everything from commercial jets to interplanetary rockets. And let's not forget about systems engineers, who bring it all together by ensuring that every part of a complex aerospace project works seamlessly as a whole. While traditional roles are essential, aerospace engineering is also bursting with cutting-edge opportunities. For those who dream big, the emerging fields of space tourism, drone technology, and commercial spaceflight are revolutionizing the industry. Imagine designing the next generation spacecraft that will take tourists on suborbital trips, or developing advanced drones that are changing everything from logistics to search and rescue operations. The possibilities are endless, and the innovations happening in these areas are nothing short of thrilling. Additionally, the rise of commercial spaceflight, driven by companies like SpaceX and Blue Origin, has opened up new avenues for aerospace engineers to work on reusable rockets, planetary exploration vehicles, and space habitats. It's an era where the dream of living and working in space is becoming a tangible reality. Now, where might you pursue these thrilling careers? The aerospace world is split primarily between the government sector, think NASA, ESA, or other national space agencies, and the private sector, which includes giants like Boeing, Lockheed Martin, SpaceX, and up-and-coming startups. Working for a government agency often means being at the forefront of groundbreaking research and large-scale long-term projects, such as Mars exploration or the development of new space stations. It's a career path marked by stability, public service, and contributing to national goals. On the other hand, the private sector offers a faster-paced environment driven by innovation, competition, and a certain entrepreneurial spirit. Companies like SpaceX and Blue Origin are known for their ambitious timelines and a culture that fosters rapid development and innovation. In addition, the world of aerospace engineering isn't confined to one country. Engineers are in demand globally, with countries like Japan, Germany, France, and India contributing significantly to both aviation and space exploration. From Europe's aerospace powerhouse Airbus to Japan's ambitious space programs, opportunities abound for those willing to think globally. Additionally, global collaboration on international projects like the International Space Station demonstrates the vital role aerospace engineers play on the world stage. It's a career that not only takes you to new heights, but also around the globe. Let's not forget one of the most important considerations: salary expectations and job outlook. Aerospace engineers are among the highest paid professionals in the engineering field, with average salaries varying based on location, experience, and specialization. In the United States, the average salary for an aerospace engineer is around $120,000 per year, while in Europe it can range from 60,000 euros to 90,000 euros. The demand for aerospace engineers is expected to grow, driven by advancements in technology, increased space exploration, and the rising importance of sustainable aviation solutions. But what does an aerospace engineer actually do all day? If you're picturing a mix of hands-on work, high-stakes problem-solving, and a dash of cosmic ambition, you're not far off. Beyond the job. A typical day for an aerospace engineer might start with a team meeting to discuss ongoing projects, whether it's a new spacecraft design, a satellite system, or a cutting-edge jet engine. Then it's on to the technical work, running simulations, analyzing test data, or tweaking designs based on findings from the latest prototype tests. Engineers might spend hours on CAD software, refining the intricate details of a wing design, or in a wind tunnel facility, observing how models behave under various conditions. It's a blend of theory and practice, where precision is key and every detail matters. Of course, the job isn't without its challenges. Aerospace engineers often work under tight deadlines and face complex technical problems. Think about it. Designing machines that defy gravity and withstand the harsh conditions of space isn't exactly easy. Whether it's dealing with unexpected issues in a prototype or navigating the regulatory maze for a new aircraft, the challenges are many. But with great challenges come great rewards. There's nothing quite like the thrill of a successful launch or the pride of watching an aircraft you helped design take flight. The aerospace industry is filled with these wow moments, whether it's landing a rover on Mars or creating a drone that delivers medical supplies to remote locations. Also, behind every successful aerospace project is a strong, multidisciplinary team. Aerospace engineers don't work in a vacuum. They collaborate with mechanical engineers, software developers, material scientists, and even biologists. Effective communication and teamwork are essential, as is the ability to integrate ideas from various disciplines to achieve a common goal. The world of aerospace engineering is constantly evolving, with new technologies and groundbreaking ideas propelling the industry into uncharted territories. Aerospace engineers are at the forefront of innovation, shaping the future of how we travel and explore space. Let's take a closer look at some of the exciting trends and innovations that are set to redefine the field in the coming years. Space exploration and innovations. With renewed interest in space exploration, aerospace engineers are playing a crucial role in missions to Mars, the Moon, and beyond. Currently, NASA's Artemis program aims to return humans to the Moon and establish a sustainable presence there, while missions to Mars, like the Perseverance rover, are paving the way for future human exploration of the Red Planet. Aerospace engineers are the masterminds behind designing spacecraft that can withstand the harsh environments of space, developing new propulsion systems that make deep space travel possible, and ensuring that astronauts can safely return to Earth. And the future looks even more promising. Imagine advanced lunar bases, Martian colonies, and spacecraft designed for long-duration missions to the outer planets or even interstellar travel. With private companies like SpaceX and Blue Origin also joining the race, we're on the cusp of a new era of space exploration where aerospace engineers will be tasked with turning science fiction into reality. However, as the world grapples with climate change, the aerospace industry is also committed to reducing its carbon footprint and making aviation more sustainable. Enter the age of electric aircraft, biofuels, and innovative designs aimed at minimizing environmental impact. Electric aircraft, once a distant dream, are now becoming a reality. Companies are developing all-electric and hybrid-electric planes that could significantly cut down on emissions. Meanwhile, research into biofuels made from sustainable sources like algae is offering an eco-friendly alternative to conventional jet fuel. Aerospace engineers are at the heart of these efforts, working on everything from optimizing aerodynamic designs to reduce drag and improve fuel efficiency, to developing new materials that make aircraft lighter and more sustainable. The challenge is to create aircraft that are not only green, but also economically viable and capable of meeting the growing demand for air travel. Furthermore, artificial intelligence and robotics are revolutionizing aerospace engineering in ways we could only dream of a few years ago. Imagine AI-driven aircraft that can autonomously navigate complex environments or robotic systems that perform intricate tasks in space where human presence is challenging. Aerospace engineers are leveraging AI to enhance everything from flight simulation and training to predictive maintenance, where AI algorithms predict equipment failures before they happen, reducing downtime and improving safety. Robotics, on the other hand, is opening up new possibilities in space exploration. Think of robotic arms repairing satellites in orbit or rovers exploring the surfaces of other planets. The combination of AI and robotics is pushing the boundaries of what's possible in aerospace, enabling smarter, safer, and more efficient operations both in the sky and in space. Also, the rise of drones and air taxis is transforming urban transportation, and aerospace engineers are at the center of this revolution. Imagine a future where you can hop into an air taxi and fly across the city, bypassing traffic congestion and reducing commute times. Companies like Uber Elevate and Joby Aviation are already working on prototypes, while drones are being developed for everything from delivering packages to conducting surveillance. However, integrating these new vehicles into existing airspace systems presents a unique set of challenges. Aerospace engineers must solve complex problems related to air traffic management, safety regulations, and noise pollution. The goal is to create a seamless urban air mobility ecosystem where drones and air taxis can operate safely and efficiently alongside traditional aircraft. How to get ahead. Aerospace engineering is an exhilarating field filled with opportunities for innovation and discovery. If you're ready to soar to new heights in this dynamic industry, here's your ultimate guide to getting ahead and making your mark as an aerospace engineer. Firstly, network and find mentors in the industry. Connecting with industry professionals can open doors to new opportunities, provide valuable insights, and help you navigate your career path. Attend industry events, join aerospace forums, and leverage platforms like LinkedIn to expand your network. Mentorship is equally crucial. Seek out seasoned engineers who can offer guidance, share their experiences, and help you avoid common pitfalls. A mentor can provide advice on career decisions, introduce you to influential contacts, and help you set and achieve professional goals. Remember, mentorship is a two-way street. Be proactive in your communication and show your appreciation for their time and wisdom. The aerospace industry evolves rapidly, and staying ahead means committing to lifelong learning. Secondly, pursue advanced degrees, certifications, and specialized training to deepen your expertise and stand out in the field. Online platforms like Coursera, edX, and Udacity offer courses in aerospace engineering and related technologies that can help keep you updated on the latest advancements. Stay curious and embrace new learning opportunities, whether it's through formal education or self-study. Read industry journals, attend webinars, and participate in workshops to remain informed about emerging technologies and trends. By continually expanding your knowledge, you'll be well equipped to tackle new challenges and drive innovation in aerospace engineering. Thirdly, joining professional organizations like the American Institute of Aeronautics and Astronautics can provide significant benefits. These organizations offer networking opportunities, access to industry resources, and a platform to share your work and ideas. Membership often includes subscriptions to journals, newsletters, and invitations to exclusive events. Attending conferences and workshops is another fantastic way to immerse yourself in the field. Events like the AIAA SciTech Forum or the International Astronautical Congress bring together leading experts and enthusiasts to discuss cutting-edge research, technologies, and industry trends. Engaging with these gatherings allows you to learn from the best, exchange ideas, and stay current with the latest developments. While technical skills are essential, soft skills are equally important for a successful career in aerospace engineering. Focus on developing leadership qualities, project management abilities, and adaptability. Strong leadership skills will help you guide teams, make strategic decisions, and manage complex projects effectively. Project management skills are crucial for overseeing projects from conception to completion, ensuring that they meet deadlines, budgets, and quality standards. Adaptability will enable you to thrive in an ever-changing industry, where new challenges and technologies constantly emerge. Invest time in building these soft skills through workshops, leadership training, and real-world experience. To keep up with the latest news and research in aerospace engineering, you can visit top industry websites and publications like NASA for updates on space missions, research, and technological advancements. AIAA, the American Institute of Aeronautics and Astronautics, providing resources and news related to aerospace engineering, or Space.com, which offers news and articles about space exploration and technology. Not forgetting Journal of Aerospace Engineering, a leading journal publishing research on aerospace engineering topics. In conclusion, stepping into the role of an aerospace engineer plunges you into a realm teeming with potential and excitement. This field presents a wealth of opportunities, ranging from crafting advanced aircraft and spacecraft to pioneering space tourism and sustainable aviation. With options spanning the stability of government positions and the rapid innovation of the private sector, aerospace engineering serves as a springboard for professional advancement and trailblazing achievements. So, if you're ready to take flight in your career and explore the far reaches of possibility, aerospace engineering might just be your perfect launchpad. Thanks for watching. Please remember to subscribe, hit the like button, and turn on your notification bell. See you in our next video.